What's up guys, today I'm going to be showing you how to build this awesome 3D printed Iron Man helmet with working servos and LED eyes. Now this video is going to be a part 1 on the full build process for this helmet. In this video we're going to be talking about 3D printing, how to get the files for a helmet like this and get them on Cura, sliced, and onto a printer for printing. To get started, I want to talk about the materials that it requires to build one of these. To start off with, you're obviously going to need a 3D printer for actually building and printing the physical parts. You're going to need a PC or a laptop to slice the files and get them onto the 3D printer. You're going to need the filament, the actual material that the printer is going to use to make the helmet. Now you're also going to need an Arduino Nano to control the servos in the helmet for the mouse movement as well as the LED eyes. You're going to need a couple bar magnets for your jaw piece to make it to where it'll pop on and off. This makes it a lot easier to put the helmet on and off. Now you're going to need the servos to control the mask. You're also going to need a wiring kit or extra wires to actually run from the servos to the Nano as well as the eyes to the Nano. As far as getting this beautiful finish for this helmet, you're going to need some filler primer, some Bondo to get rid of big marks, as well as the paint, which includes the gold, the red, and the gray. As well as to get this smooth finish, you're going to need some sanding paper. That includes 80 grit, 120 grit, 220, and even up to 600. Now for this helmet, a portable battery pack works great, but for my suit, I have a big battery pack that powers everything. That should cover everything you need to make this full helmet. There may be a few odds and ends here as the build process goes along, but that should be everything. But as far as for this video, as getting it 3D printed and on the printer, all you will be needing is your 3D printer, a laptop, and your filament. All the materials used in this video and for this helmet will be in the link below. Now as far as filament goes, my two favorite is Ceramic PLA Plus and Elegoo PLA Plus Rapid. They both work really great. For the ceramic, if you have a slower printer that's printing between 50 to 70 millimeters a second, that'll work great. If you have a printer that can print to 150 and higher, you're going to want to go with the Elegoo Rapid PLA Plus. Now once you have your printer, your laptop, and your filament of choice, you're going to want to try to find a good helmet file to use. Now on Thingiverse, there's a vast majority of helmets to use. I'm going to show you the ones that I've used and printed personally, and the one I'm going to be using today. The first file I want to show you is by a creator Budwin on Thingiverse. This is a free file, and as you can see here, this is the helmet pictured. Now this is a good helmet, it has a great shape. I didn't have to scale it much, which is also great. It has a detachable jaw by the earpiece. So this is a good helmet. This was my first try. Ended up having servo issues, so I never finished it. The next helmet, this is the one that I used by Sam Butler. It's a great helmet. I ended up having to scale it a little bit bigger, I believe, but I really love the shape as well as the way the jaw detaches. It attaches from the ear here instead of at the ear. So the helmet we're going to be using today is a file from Do3D, the Mark 85 V2 Iron Man helmet. I really like this helmet because of the motorization in it. Now, on the helmet that I have now, as you can see, when the mask comes up, it is a little crooked, and I'll tell you why. On these helmets, the mask has several arms that allow it to pivot and rotate to fall perfectly in place. The reason why I'm using this Do3D helmet is because it has the perfect placements for all of the arms and the motors. When using a free file off of Thingiverse, you're going to have to use the Crashworks motorization kit, and with that, you have to manually place all the arms and pivot points yourself. Now doing this can be very hard because you have to put them in the exact position to get the perfect alignment of the helmet. Now as you can see, the helmet is lined pretty good when it goes down, but when it goes up, it's a little cockeyed, and I do not like that. I want to use this helmet and get the perfect motorization. So once you have the helmet you want, you're going to want to download the file, whether it be from Thingiverse or in my case Do3D's site. You're going to download the files, and if you're on Thingiverse, just go to Files and click each of the download buttons or download them into a zip file. Now once you have them downloaded, you want to go ahead and make sure that you have Ultimaker Cura. This is going to be the slicing software that we're going to use to get the 3D print onto the printer. If you don't already have it, go ahead and hit the download for free button, and this should get you started. Now once you're in Cura, go ahead and go up to the top left here, that folder icon, and go ahead and import all your files. So now that your files are in Cura, you might be asking yourself, how big do I make the file? And I'm gonna help you out with that. One great resource for sizing files is the Sizing Heads by Budwin on Thingiverse. Now Budwin has made 4 different heads that are all sized differently, and what you're gonna do is measure your head and select which head on Budwin's post matches yours the best. Now I've already went ahead and measured my head, and I know that head 3 is the head for me, so I'm gonna go ahead and download that and import it to Cura. Okay, now that you're in Cura, go ahead and import your head. Mine is gonna be in downloads. Okay, now that our head is in Cura, we're gonna go ahead and assemble our helmet inside of Cura so that we can put the head inside the helmet and get a good idea of what size we need to make our prints. If you click an object and then shift click onto your other object, you can move them in unison. Okay, now that we have our helmet assembled, we're gonna go ahead and click all of our pieces. Shift click, that is. Click all of our pieces and then right click and hit group. And now we can move the whole helmet as one. Next, we're gonna go ahead and move our head from Budwin inside the helmet. And let's go ahead and put them on the same x-axis number. So we'll copy the helmet axis and paste it to the head, and now they're gonna be centered up. And now you can manipulate the helmet and the head to get the best fit. I'm gonna actually ungroup them so that I can pull the faceplate off and see how the head fits inside of it. Now, I actually think this helmet is going to be a little too small for me, so I'm going to scale it up to 105%. This should give me enough room for our motorization kit and the arms to be installed, as well as the Arduino up top. So I've selected all my parts, went over to the scaling tab on the left. I'm going to be doing uniform scaling, and let's go to 105. So now that we've got our helmet scaled, I'm going to go ahead and get the faceplate on the build plate so that we can start messing with settings to get it ready for printing. Let's go ahead and click the faceplate, right click, and then click center selected. So now we're going to orientate our faceplate for the best printing. And since I've done a few of these helmets, I know that doing the faceplate in a forward orientation like this is going to be the best way to do it. As you can see, the red spots are where it's going to want to support. So it's going to build up supports here for the eyes. Now, because of all the details on the back of this mask, it wants to support all those little details as well. And I don't care necessarily for all these small details because I know my printer will print them just fine without supports, especially on this top area up here. Let's go ahead and scale these, make them bigger. And we'll slice. Now while that's slicing, let's go ahead and look at some settings. The first setting we'll talk about is quality, and the main one we're going to be looking at is layer height. Now the layer height that I like to use is 0.23. 0.3 is good for doing big builds quickly. 0.1 is going to do really small builds really finely and get a lot of good detail. Now, I find a happy medium is 0.23. This is going to make it to where we'll still have to sand, but we won't have to sand as much. The next setting is walls. Now, the only thing I change here is my wall line count. I'm going to increase that to make our walls thicker. This works well in unison with having a smaller infill, So if you have a smaller infill, it's not going to take as much material to print, but having those thick walls gives us that rigidity and make sure our parts aren't going to break. Material is dependent on what material you're using, what filament. They range in different temperatures. 210 is good happy medium and what I like to use. Speed, for my Creality Ender 3 Pro, I print at 50 millimeters a second. I could probably print a little bit faster, but that's just what I'm comfortable with. So for supports, we're going to be doing tree supports, and as well as we're going to be doing a 50-degree support overhang angle and a 3% support density. That 3% support density is going to make them much easier to remove. Now for this print, since there's such little material touching the build plate, we're going to want to do a raft here. What that's going to do is build up a lot more material around the base of this print to keep it solid and to keep it from falling off the build plate. And so that's going to be the basic settings for this print. So now that our print has done slicing, we can go to preview and see where it's going to support and where it's not. Now, I don't necessarily like these supports right here, but I'm fine with it because of these big pillars on the side that's going to keep our print from falling over. Now, these little tiny supports up here, I don't like at all. Having all this material print all the way up there, I feel is very unnecessary. So I'm going to put some more support blockers right there. Let's give it another slice. Once that's done slicing, you're going to grab your micro SD card that most likely came with your printer. If you don't have a micro SD card reader, you're going to need one of these SD card readers that go with a USB. If you don't have the SD card reader, go ahead and put it in your USB stick and then enter this into your computer. Now that our print is done slicing, we can go ahead and preview and see where all supports are going now. This print is going to take 2 days and 1 hour, which is quite a long time, but for a faceplate like this, that's reasonable. What you're going to do is I like to name my files so they're easy to see on the printer. So for this one, I'm going to be doing Iron Man faceplate. Then we're going to go ahead, save to removable drive. Once that's done saving, you're good to eject it, and then you're ready to put it in your printer. Now that you have your files on your SD card, go ahead, insert them into your printer and start printing. Some things that I like to do before I start printing is clean the bed. You can do this with acetone or alcohol. This will help with your bed adhesion. Some other things that I like to do is make sure that your bed is level. Go through the bed leveling process for your specific printer. This is also going to help with bed adhesion. Lastly, make sure you have the correct filament in and then get to printing. Stay tuned for part 2. We're going to install the eyes, the servos, batteries, and magnets.